Hello and welcome to IITN Academy. In this session, we will learn about graphical representation of motion. We will now discuss the various types of graphs which can be used to calculate speed or velocity, acceleration, and distance traveled by a body. We will first study the distance-time graphs and then speed-time graphs or velocity-time graphs. Please note that in drawing graphs based on motion, time is always taken along the x-axis, whereas distance or apostrophe, speed or velocity is taken along the y-axis. Distance-time graphs. When a body moves with uniform speed, it will travel equal distances in equal intervals of time. In other words, the distance traveled is directly proportional to time.
You have learned in the previous class how to represent y-axis and x-axis while drawing a graph. So here you see this is called the y-axis and this is called the x-axis. Now while drawing velocity or a distance time graph, we will use y-axis always as a distance or velocity, and x-axis is always a time. So basically, if you want to have a distance time graph, then plot distance on y-axis and time on x-axis. Similarly, if you have to draw velocity and time graph, always use y-axis for velocity and x-axis for time.
The distance graph of a body moving at uniform speed is always a straight line. In other words, straight line graph between distance and time tells us that the body is moving with uniform speed.
If you see here on the y-axis we have the distance and at the x-axis we have the time. So this is distance time graph. So you see the y-axis and this is the x-axis. Now in uniform speed, this graph of distance versus time is always a straight line. So for example, you see here the distance traveled is 10 kilometer and then this is the time here. Okay, similarly this point, you see distance traveled is 20 kilometer and this is the time here on this axis, x-axis. So if you take this point on the x-axis, this will give you the time. So this from here to here is time, and if you take it on the y-axis, it will give you a distance. So basically distance time graph, remember, if this is a straight line, then this is uniform speed. Okay, so in exam the questions comes like distance time graph is a straight line, whether it is a uniform or non-uniform speed. So what will be the answer? Answer is, if distance time graph is a straight line, then this is uniform speed graph.
Distance-time graph of a body can be used to calculate the speed of the body. The slope of a distance-time graph indicates speed of the body.
Yeah, so here what we are saying that from distance time graph we can calculate the speed of the body. So for example, if you are given this distance time graph like this, then what is the speed that we can calculate? So what we are saying that in a distance time graph, the speed is basically the slope of this line. So for example, this line is like this, so this is the slope. Now what you have learned, speed is basically the distance traveled by time taken. Remember, in last class you have learned speed is equal to distance traveled by time taken. So for example, let's take this point O to A and then to B. So for example, this car travels with a distance and time on this graph. So here you see this point. If you plot on y-axis, this is S1. Okay, so distance traveled at time t1 is S1, and similarly distance traveled S2 at time t2. So now a speed is basically, we have learned, the distance traveled by time taken. So from here to here, remember in the last slide we said that if you plot this point on y-axis, it gives you the distance. So what is the distance traveled? It's basically the car traveled, this was S1, and then it traveled to S2. So distance traveled is how much? S2 minus S1. So this is S2 minus S1. And how much is the time from here to here is basically T2 minus T1. So this is T2 minus T1. So speed is basically what? The distance traveled by time taken. So from a graph, if you are asked to calculate the speed, what you will do? You see what is the distance on the y-axis, delta of it, and then you see how much time it took, and then you divide distance traveled by time taken. It will give you the speed.
Table shows their distance traveled by a car in a time interval of 2 seconds. The distance time graph for the motion of the car is for this table is shown in next slide. It is not uniform.
So here you can see the car travels in every 2 seconds. See, every 2 seconds. How much distance? It's 1 meter, 4 meter, 9 meter. So here see, in every 2 seconds, the distance travels are different. So here is 1 meter, here is 3 meter, here is 5 meter, So every 2 seconds, the distance traveled is different. Now how this graph for this table looks like, we'll see in the next slide.
We have seen above that if the speed of a body is uniform, then its distance time graph is a straight.
So we have seen in uniform speed time graph how the graphs looks like. So it was like something like this. Okay, so this was y-axis, this was x-axis, and this was distance, and this was time, and the graph was like a straight line. It was a straight line. Okay, now let's see how the graphs looks like in non-uniform
line as shown in last figure. If, however, the speed of a body is non-uniform, then the graph between distance traveled and time is a curved line called a parabola, as shown in this figure.
So you see here, this is distance and this is time. So distance always on y-axis and time always on x-axis. Now here you see these curves, this speed time graph is like this. Okay, but in the last uniform speed what we have seen, this is like a straight line. Okay, but here you see this is like parabola. So this is called, a straight line is called what? Uniform speed graph. Okay, so distance time graph which has a straight line is called uniform speed graph, and if distance time graph is a curve, this is called non-uniform. Okay, so non-uniform is what? It travels on equal distance. We have seen in the last slide this 1 meter, 2 meter, 5 meter, so for every 2 seconds. So here in non-uniform is you travel unequal distance in equal interval of time, but here in uniform you travel equal distance in equal interval of time.